Welcome to today's session. Today we are this particular session is on non-special data model. Basically, in the GIS, what you are learning today is basically in this course is how to handle the geospatial data and how to extract the information from the geospatial data. So, in geospatial domain, the non-spatial data is equally important. If you compare the spatial and non-spatial data together, the basic difference between these two data model is the location specific information. If it is a spatial data, then you are storing the location information in the form of the coordinate or maybe some other form like a projection system and all. So when you are storing this information in the GIS, so it is equally important to link this spatial data with attributes, and attributes are known as a non-spatial data in GIS domain. And the attribute plays very important role, and these data may come sometime from some literatures. You can also collect this non-spatial data through the ground truthing or maybe ground survey. And these data, when you'll be geotagged or you'll be tagging with this spatial data, then it will be very useful for GIS to do the many analysis or to conduct various kind of processes in the geospatial domain. So how to handle this data? First, you have to understand what is this data. Basically, if you see in around the word like your name of the buildings or the more detail about the buildings, name of the roads or the length of the roads, width of the roads, or sometime you can see the flow of the traffic in the roads. Similarly, this data you can also refer to the value physically recorded in the database. To manage the data, we should have a database management system. And the database, basically, when you are talking about the database, today we have the various options available with us in the open source and commercial environment that we will see in detail in coming lectures. But today, let us try to understand first about the physical entity of this data, how this data is being stored or collected in the computer system. When you are collecting the data, storing the data in the computer system, then how to manipulate this data and how to retrieve the meaningful information from this data is very important. So if you see here, in general, when you are using the computers, we'll be storing our data sometime in the plain text editors, something like Notepad or text editors. These are the simplest way to store or to create data in a computer system. And these text editors allow you to read and retrieve the data anytime once you are stored in your computers, and physically it will be shown as a file, and the file based systems basically line by line will be keeping the data inside the text file. The another form of data storage or data collection systems basically we consider as a word processor. And word processors also similar to your MS Word or maybe OpenOffice. These are the typical examples where you can also create some tables within the documents. You can format your data or maybe your documents, like you can keep it as a bold, italic, formatting, presentation methods, you can change it. And also it can give you the opportunity like to search some typical or a particular data contents from these files, and many advantages are there. After that, the next format generally what we are using in our computer system is spreadsheet programs. Spreadsheets like your Excel sheet where you can store your data, or especially it is good for the analyzing the numerical data sets. If you talk about the plain text editor and word processor, they are well known for the textual data or the data where the characters or sentences are available. If you see in the computer system, the text, the characters or sentences or numeric values all are coming under the data category. These are very important for us when we are store this kind of data or information in our computer system for future use. But typically, if you see the advancement of the spreadsheet or word processor plain text editor is known in the form of the database management system. And this all three methods like text editor, word processor, spreadsheets are good to store a very limited data sets or to analyze these limited data sets. But if you want work with the large data sets or you have the big data in your computer system, the effective database management system is very important. And here you have many options, and you can define the different data formats, you can define the structures, you can also define the rule to read and write or to manipulate this data using the DBMS methods. So DBMS or database management system is another methods, another way to store and manage our data inside a computer based system called as a DBMS. So if you see typically, let us try to understand a little more what is the database system. Basically, it is nothing more than a computer based record keeping system. So here you are just managing your records, and the overall responsibility or purpose of this system is to record and maintain the information. So database system is basically a computer based record keeping system whose overall purpose is to record and maintain the information and a very large integrated collection of data. So when I am saying the database system is integrations and collection of data. If you see here in the database system, we also integrate the models. A model basically is a abstract representation of the real world entities, or whatever we are seeing in the real world. If you make the abstract representation of it inside the database system, so that is known as a model. And here we use one term called entities. Entities like students, or example of entities like students like Amit, course like DBMS 64. So database management system, course number 64, if Amit is attending, then you can understand this way, the Amit is an entity and the course like DBMS 64, these are the entity. And their relationship basically, if you understand here, so Amit is taking DBMS 64. So what does it mean? So here relationship between the entities and their relationship we can define inside the DBMS. This is one of the important advantage to store and manage data inside DBMS, and this will be very very critical and important when you work with this special data, when you try to link your attribute data with the special data. So basically a database management system is a software package designed to store and manage database. Basically this DBMS packages, you can consider many are available today. We'll see what are these things. But basic objective of the DBMS is how to store, how to effectively store and manage our data inside the software package. So it is basically a software package which will give you the opportunity to do many data analysis processes, and it will also provide many tools for this purpose. So typically if you see the growing standards of databases, in 1960s this particular concept basically of file based system was started. Here the flat files like your text file, or like a text editor or notepad or notepad plus any tools are there. So basically flat file systems were introduced. After that we start to understand the network or hierarchical based systems, similar to your folders, subfolders and file based concept, when the data is structured in the hierarchy mode for the better searching and or to relocate the data quickly. This is one of the methods. But in 1970s time period, when 1973 time period, sometimes I can say, a French mathematician, Dr. E.F. Cole, introduced the concept of relational database management system or database management system. That time the concept was how to store and manage the different kind of data set in the form of the tables. And today still this is one of the best method to store and manage the database. And basically the DBMS or RDBMS concept was designed for the textual or numerical data. But today, people are using the same concept for the geospatial data or for the GIS specific data, and sometimes it is known as a GeoRDBMS or sometimes known as a geo database. There are many terminologies are being used. But further, if you see the extension of this particular technology, today the database system is moved toward the distributed database systems, where the web services based concept is introduced and where the XML or SOAP protocol is used for sharing or for inter exchange of the data from one standard to another standard. So in this particular lecture session, we'll focus only up to this DBMS and RDBMS part, because these are the tools, or I can say is an effective tool to manage our non-spatial data. Now, if you see the basic component of database system, we have the four components here. One is a data, second is a hardware, software, and users. So any software which is known as a database management system or database systems, this will have always four components: data, hardware, and software, and users. Let us see. So if you see, the data is a basic requirement of database system. Is any information related to an organization that should be stored for any purpose according to the requirement of the organization. For example, if you are talking about the banking system, so all the information required to manage a bank will be basically a data. So with the database, user should be able to store this data in organized manner. So basically, effective data organization tools it will provide you, and effectively you can manage the data using the database system. So data is a basic requirement of your database system. A database is a repository of stored data. When you are storing a interrelated data sets in a repository, so basically it is known as a database system. So we can say it is a repository of the stored data. In general, it's integrated and shared. That is very, very important point here. So data is integrated. It's a interrelated data what we are storing here. So similarly, for example, if you take the example of GIS, if you are doing the mapping of a particular area, for example, for the land use classifications. So now, if you are interested to create the data for land use, there are two components. One is basically on the land use classes, or maybe you can say that this particular piece of land is categorized as a cropland. But this cropland, what type of crops are grown there? So this particular attribute will be tagged, will be storing in the separate repository, which will be basically non-spatial data repository. And with the concept of the key or relationship, we can link these two data sets together. So in general, you can say that it is integrated. When I am saying the integrated, another important point of this particular issue is it should be shared. So when I am creating my data, so I should have opportunity to share this data effectively with my other users. So database system also will provide you opportunity to share this data with the other users. Without replicating the data, you can share it. Second component is a hardware and software. So it consists of secondary storage like your disk, your DVD, CD, or any secondary media, which database reside together with the associated devices, control units, and channels. So it is basically between the physical database stores, and the user is a layer of the software usually called a database management system. All requests of the users are handled by DBMS, and DBMS provide a view of the database that is elevated somewhat above the hardware level and support user operations. So when you are saying the hardware and software, basically these are the medium to physically store the data and to manage the data. When I am saying that physical storage, it is basically your disk, your storage media, and software is basically a set of rules to manage this data or to analyze this data. These are the important component of database management system. And next component is a users. Users are most important in the database. In database system, typically the users are categorized in three major categories. If you see here the category of the users, first is a end users. And end user basically accessing the database from the terminal either through a application program or the query language can perform all the function of retrieval, creation, deletion and modification. So end user basically it can be any layman sometime also of my data sets. And if you see the typical characteristics of this particular user is this particular user is interested to extract the information from the data, and how to get this information from the data is basically through some application program. And the application programs are developed by the application programmers, and these are programmers basically responsible for writing application program that use the database in any programming language like C, Visual Basic, Java, Python and all the DBMS operations are performed by issuing the appropriate request from the application program or DBMS. So application developers are also one type of users for database management system. One is the end users. End user is accessing the data through the application program, but the application program is developed by the application programmers or developers, and they are the another kind of user of the database system. And the most important user of this particular database system is a database administrator. And the database administrator can view as the household person of the database system, whose responsibility is to keep the system up and running and to make sure that it performs as efficient as possible all the time. So it is known as a DBA, database administrator, will have the full control on the database, and also it will this particular person will implement many policies, rules on the database, and also make the secure data, and also this person will ensure that data is available on 24/7 basis. So availability of data is another responsibility or important responsibility of database administrator. So these are the three basic type of users in database system. Now in general we understand that in our normal routine lives, if you organize the data in computer based systems, there are four type of database organization systems are available. One is a flat file, we have seen hierarchical, relational and object oriented. So flat file and hierarchical is a typical or a very traditional method of storing and managing the data. As I explained in beginning itself, that it can be a text file, it can be a folder, subfolder and file kind of type of concept. But relational database management system and object oriented database management systems are most important. So we'll try to understand these two type of database organization methods in today's class. One is a relational, second is a object oriented. So next question comes that why we should use this database. When I can store my data in my Excel file, when I can store my data in the Excel file, then why I should use the database management system or DBMS. So a DBMS basically it provides the enterprise with the centralized control of its operational data. So that is very important. It's a centralized control of operational data. If you see the typical file based system, for example, if you are working in a word processor like MS Word file, and yes, this particular file also can be shared with the users within a network environment where you can keep your file in a folder and you can allow the sharing, and you can give the password to your colleagues or friends. They can also visualize your files, can see your data. But in the file based system there are many limitations. The most important limitation is only one user can access this file at a time. So multiple user cannot edit, cannot open this file. Only a single user environment we can say here. Second important or critical limitation here is the performance of data access is very slow. If suppose we have a MS Word file of thousands of pages and we want search or we want extract a particular part of this data, it will take long time to extract this information. So this is another kind of limitation, and there are many more such limitations available in file based system. So large data cannot be stored there, And if you see in the database system, what are the advantages you are going to get if you are using this particular system? One is that redundancy can be reduced. Your duplicacy of your data can be reduced, and sometime we can see that you can remove the complete duplicacy in your data. So inconsistency can be avoided, data can be shared, standard can be enforced, security restriction can be applied, integrity can be maintained, conflicting requirement can be balanced, and concurrent access recovery from crashes. So one by one we will see all these advantages and we'll try to understand in detail in coming slides. First point or first advantage to use this database system is basically redundancy can be reduced. When we are saying the redundancy means it's a duplicacy of data. In a non-database system, each user has to its own private files. So that is another important limitation in the file-based system. If you want to share the files with the users, then you have to make a duplicate copy of these files, then only you can share. And this can be often led to the considerable redundancy in the stored data when resulting waste in storage space. And this is a very important and critical point when you are working in the geospatial domain. For example, suppose you have a file-based environment for your GIS, and suppose you are involved in a activity, say for example a mapping of a particular regions or maybe mapping of a country using list 3 data, for example. And list 3, suppose it is a 60 GB in size, one image set for entire India, suppose. And if my 100 users are working with this particular list 3 satellite imagery, in the typical file-based system, I have to make the 100 copy of this list 3, and then you can say that 100 into 60 GB, suppose. So 6000 GB, suppose I need storage to store my data. If it is a typical file-based system. So if it is the same project, you can understand that that much money we have to invest for the storage point of view to store the data by the 100 users. If the number of users are 1000 or 10,000, the scenario will be totally different. So this kind of duplicacy or redundancy can be reduced using the database system. You will have the full centralized control of your database, and the multiple user can access this data in a same time. So this is one advantage. And the database, the redundancy is basically delicacy in a record can be removed by using the RDBMS concept. This typical example I was telling in case of list 3 image, but similarly similar kind of duplicacy is possible in your records. Maybe a student entry is multiple time in a table. So how to remove it? So if you are putting this in a standard Excel file or MS Word document, sometime it will not be possible for you to stop the duplicacy in the record. Sometime by mistake also multiple record for a single entry are possible. So in the database you can apply the rules and you can use the concept of RDBMS, and this kind of redundancy you can remove or you can reduce in your database system. Second point, what we discuss about the inconsistency can be avoided. If you see, suppose employee Amit work in a department system, is represented by two distinct entities in a database, and that the system is not aware of this duplication, and redundancy is not controlled in this case, then it may be possible that the two entities will not agree, like only one record is updated. At such occasion the database is said to be inconsistent. So if you try to understand little more here, suppose an employee in an organization is working in a two places or in a two projects, for example project A and project B, that is always possible. And in project A the detail of a person or employee is entered there. This person is name is XYZ, qualification is this, skills are this, and working in this project from this date, or maybe other detail of personal detail. But suppose this, and the same person is working in some other project also, in there also the person is having similar kind of entries, but sometimes the person has got some extra qualifications or some skills, and these skills are updated in one database but not updated in other database. So these kinds of inconsistency are possible in a non-database systems, and this is one example. There could be many examples, such examples where the inconsistency are very critical, and it can be avoided basically in the database system and by using the certain rules of database or RDBMS. If redundancy is removed or controlled by the system, then such inconsistency cannot occur. So if duplicacy of a record is not existing in organization, that this kind of inconsistency will not be there. Next is the data can be shared. Of course, we discussed earlier also, the same data can be shared by the different application. No need to create a separate database for different application. That is another important advantage here. So no duplicate copy or multiple copy of this data is required in case of database system. These are the another important advantage of your database system. And next point is, if you are using database system, the standard can be enforced. With the central control of the database, the DBA can ensure that all the applicable standards are followed in the representation of the data. So when you are applying a policy with the data set, that for example, if you see the salary of the employee, the salary will be always a number. Nobody can enter any tax in the salary, or maybe sometime you can say the maximum salary of the organization is that much. Nobody can enter more than this particular number. So this kind of rule you can always apply, or you can enforce in your database tables. So that's why we say here is a standard can be enforced in a database systems, which are very important for the effective management of the data. And next, very important, is a security restriction can be applied. So you can apply many security restrictions, or maybe a DBA, a database administrator, a responsible person for the managing the data, can ensure that the only means of access the database is through the proper channel. So when you are entering the data is coming proper channel and entered and qualified and checked by a person or identified person to receive the correct data set in our database system. The DBA can define authorization check to be carried out whenever access to sensitive data is attempted, and different check can be established for the each type of access. So very easily these checks can be implemented for ensuring the secure data flow in a database system, which can be nicely implemented by DBA as a rule in the database management system. Next point is the integrity can be maintained. So integrity of data is very important. If suppose you have the gigabyte or terabytes of data with you, and if this data is not reliable, then there will be no use of this data set. To ensure that database is accurate, the inconsistency between two entries representing the same fact is an example of lack of integrity. For example, you can see here, an employee may be shown as having worked 200 hours in a week. Okay, sometimes if it is a 20 hour by mistake or human mistake or typing mistake, one extra zero is included here in a standard file based system, the computer cannot stop it. But in the database system, this kind of mistakes are not possible, because if you see that in a week, automatically to understand that the maximum hours, say around 40 or 42 hours in a week are permitted. If somebody is entering more than this, automatically it will stop. So it is a one typical example where the consistent data will be maintained in a database system, and the centralized control of the database help in avoiding the situation insofar as they can be avoided by permitting the DBA to define validating procedures. So DBA can write a procedure to validate the data or to validate the accuracy of this data through the rules. This is another important advantage to the database system. So conflicting requirement can be balanced. So the DBA can structure the database to provide an overall services that is best for the organization. So here the conflicting requirement of different departments within the organization can be managed. And how to manage it? By applying the database rules and the policies with your data sets. Now let us try to understand when it is in place. Then the DBMS, as I mentioned, that it is a basically a software package which will provide you a platform or environment to store, manage and analyze your data effectively. So this particular package or DBMS is a program that enables user to create, manipulate and maintain the database. Some of the example of these DBMS are Oracle, PostgreSQL, MySQL, DB2, SQL Server, MS Access and all. And there are many more such database systems exist today for the effective management of your attribute data. Basically, we talk about attribute today only, so that is possible. Nowadays, these database systems are capable to store and manage our geospatial data, your raster and vector data also. So you can use the single platform or single environment to store your spatial and non-spatial data, and very powerful tools are available there. If you see here, the Oracle is a commercial package, PostgreSQL is a freeware open source package, MySQL is a freeware very popular package, and the DB2 is again is a proprietary, SQL Server is again proprietary, MS Access is a proprietary. There are many such examples exist today, and these are some of the popular database management systems available in the industry. You see the characteristics of the DBMS. A DBMS software package for defining and managing a database. A real database includes the definition of field name. Field basically we take as an attribute name, and data format like it is a textual data, binary data, integer, float, real number, is a textual, alphanumeric. These are the basically data format, and these formats basically known as a data types in DBMS. And we'll see later stage also. And data types are very important to define our data. And the beauty of this particular architecture of DBMS is it can manage different kind of data as object also, because nowadays the concept of object orientation is introduced in RDBMS, where effectively you can define your own data types. You will be knowing about this concept in later stage, but right now you should understand that there are different kind of data format which are stored in DBMS and by using the data types. So record structure like fixed length, pointers, field orders, these all you can define there in the DBMS. Then file structures like sequential indexing, and these all things are possible there. But it is not a file structure, it is a record structure. But files structure generally, if you see, we use the concept of the sequences and indexes in the DBMS. And then we have the rules for validating and manipulating the data, and these rule can be defined as a procedure, as a function in the DBMS itself. And of course, most important characteristics for the DBMS is the data, without which nothing will work there. So it's one of the important component of DBMS. And if you see the component wise in the DBMS, we use the data definition language, we use the data manipulation language, and sophisticated general purpose query language, a facility for concurrent access of data by the multiple users, a facility for security and integrity controls. These are the component of the DBMS. The most important component is a DDL and DML. Basically, these are the two languages. These are not a programming language. We call it a data definition and data manipulation language, and within the structured query language. So SQL, the structured query language, is a language, and in fact you can understand it like basically a medium to communicate between the user and the database. So these are the basically standard for this. We'll understand in later state what is DDL, what is DML. And right now you should understand that data definition basically how to define the structure. For example, if you want to create a table, so how to create a table, like a simple statement of the SQL like create table student, then you will define the structure, then name of the student as a character, or age of the student, date of birth as a date, or class XYZ you can define. But when you are interested to manipulate this data, for example, I want to know how many students are there in class X. So that time you will be using data manipulation language. So basically you have to understand there are two kind of components are available, DDL and DML, and these components are defined or are for the structure query language. Some of the terminologies what we will be using in the database is basically entities, already discussed, are basic units used in modeling classes, concrete or abstract object, example room, chair, employee, etc. And the attributes like field name. For the record set, we'll say the row value as a record set. These are the some of the terminologies in database people will be using it. Another important terminologies what are being used here is a key concept, is a single attribute or combination of two or more attribute of an entity set that is used to identify one or more instance of the set, like a primary key, super key, candidate key, and alternate key. These are the some of the example. We will not go in detail of this concept, but quickly you understand here. When you are using term primary key, basically it is an attribute which will be used for the unique identification of the record. For example, for the student record, and if you want uniquely identify a student, then you should have the roll number of the student or registration number of the student. So registration number can be used as a primary key that time. So it's a unique identification of the student, and this is known as a primary key in the database, and is very important component when you are using the DBMS or RDBMS. So next component is a super key. If you add an additional attribute to a primary key, the resulting combination would still uniquely identify an instance of the entity set. So for example, suppose we have some primary key or we have the unique identification number of a student, but sometimes it is not possible to define or to uniquely identify a record by single attribute, then we can add an additional attribute, and this particular combination of unique ID and additional attribute, it will be known as a super key. That is basically a additional attribute you are adding in a table which doesn't exist in general, but it is required to uniquely identify the record. So this will be known as a super key. So candidate key is basically two or more attributes or combination of attributes that uniquely identify the instance entity set called as a candidate key. If it is a combination of attribute, then it's a candidate key. If it is a additional attribute you are adding to uniquely identify the record, then it is a super key. So in the database terminology, one important terminology people will be using is ACID. It's a database basically on the atomicity, consistency, isolation, durability. It's a very popular word and is a set of the properties that guarantee that database transactions are processed reliably. In the context of database, a single logical operation on the data is called transactions. Very important. So transactions, when it is happening, when the transaction will be complete. What is the definition of it? For example, you may be using this ATM cards nowadays in a banking system. Suppose you are using your ATM card and you just swipe your card, enter your PIN and try to take some money, and in between there is a power failure. Everything was done. In fact, many times you will be receiving some SMS also that much money is deducted from your account. But if it is not database that time implemented for this kind of transactions, then the completeness of this transaction, how to define, is very important. Until unless the machine is not giving you money and you are not taking money out from machine, the transaction cannot be considered as a complete transaction. If in between power also fails, or if there is some problem in machine itself or some issue happens, that time you will see that although money was deducted, but after some time this money will be refunded to your account, which since transaction was not complete. So this kind of consistency or basic durability are possible in database only. To do this, we have the terminology called atomicity, consistency, isolation, durability. We'll see in detail in coming slide. Here you see here a transfer of a fund from one bank account to another, even though that might involve multiple changes such as debiting one account and crediting another account is a single transaction. It cannot be considered as two transactions. It's a single transaction. Taking money from one account, transferring to another account, it is a single transaction. And this kind of relationship and how to define a single transaction in that case, that things are possible in the case of database, and it is known as a database durability. Little bit detail about these four terminologies: atomicity, consistency, and isolation and durability. You can see here when I am saying the atomicity means it required that each transaction is all or nothing. Very important. Either transaction is complete or not complete. In between, no definition. If one part of the transaction fails, the entire transaction fails. As I mentioned that you have entered amount is deducted from your account, but money is not received. That means the definition of this transaction is transaction fails. And database state is left unchanged. So state will not change, of this database state will not change. So an atomic system must guarantee atomicity in each and every situation, including power failure, errors, and crashes. So this is very, very important when you are using the database management system. So atomicity will be maintained. So transaction will be either complete or nothing. Next is consistency. This property ensures that any transaction will bring the database from one valid state to another state. So that is a consistent data. So any data returned to the database must be valid according to all defined rules, including but not limited to constraint and then cascade, triggers, and any combination of thereof. So here, for example, why this consistency is important? In the database, there is something called triggers. And when you are doing some transaction on database, and suppose you have defined a trigger that if a particular record is updated in a table, so it should automatically update the another table available in the database. So that means until unless both the tables are not updated properly, the data cannot be considered as a consistent data. So this kind of consistency you can ensure in database management system to apply the rules. So this is very important. Next is the isolation. The isolation property ensures that the concurrent execution of the transaction result in a system state that could have been obtained if transactions are executed serially, that is one after the other. So isolated data. So isolation property basically is another important thing for the completeness of the transactions. When you are changing the state of the database from successful to unsuccessful, or maybe true or false, whatever it is. So if it is a complete, if transactions are executed, so it systematically see the one by one, step by one step it will execute, and once it will reach the last step, then only it will be considered as a complete transaction. So it is called as isolation. And then durability, it means that once a transaction has been committed, it will remain so even in the event of power loss, crashes, or errors. In a relational database, for instance, once a group of SQL statement execute, the result need to be stored permanently, even if the database crashes immediately thereafter. So once the transaction is complete, immediately it has to be complete all the process of writing the database in all the data tables on data files. So here the durability is most important and critical, because it is not necessary every time you will be storing data in the single computer. Many times people are using the multiple computers or multiple networks to manage the data. So these are the things possible in basically in database system, and these four terminologies are very critical and very important characteristics of a database system. Now, next important point comes is the data models. What do you mean by data model basically? Data model is a collection of concept of describing the data. So in general also, as I mentioned in beginning itself, when you are saying the model is basically abstract representation of the reality. So it's abstract representation of the reality. Basically you are trying to simulate reality in the computers. The same concept data model is basically how to describe the data in the computer system. To do this, you need a database schema. If you see the schema basically overall structure of the database. It describes basically description of a particular collection of data using the given data models. So here different kind of data models exist today. So one of the most popular data model in the DBMS is the relational data model, is basically mostly used for the modern today's in today's environment, and here main concept is the relation and schema. So tomorrow we'll see in detail about the relational data model, and this particular data models works on the principle of Dr. E.F. Cord, where the 12 rules are defined for this. So there are many such model exist. Is one RDBMS model, ORDBMS model. We have the for the GIS also, like raster vector data model. In database also different data model exists today, and most popular is the RDBMS. So a data model is a formal language that allows us to define the type of data and data processing that occurs in a database application. It supports basically definition of data structure for storage, definition of rules that the stored data have to obey, and definition of operations on the data such that changes to represented things in the real world can be accounted. So basically data structure, rules, operations. These are the three important components of a data model. How to define the data? It's a data structure, schema we called it. What are the rules applied on this database? That is another important point. And what kind of operations are possible in this data is known as a definition of operation of data. That is another important component of it. Like, let us try to understand the relations, like an example of relation you can understand here. This is one schema, student. Within the student is a student ID, and ID is defined as a character, and the length of character could be 5 in number. Name of the students, and the definition of this name is varchar. It's basically alphanumeric kind of or sentence kind of things can be placed here. So 20 is the length of his name. Login is a like a varchar again, any alphanumeric character can be used. Age is a integers, and GPA is around real. It's a basically 9.6 or 8. Whatever it is. Now relation instance has basically cardinality 3, degree 5. So what does it mean? This is basically a algebraic representation of it. Suppose this is a table you are seeing here, and here student ID like a 53666, name is John, and login is John at CS, age is 18, and GPA is 3.4. Second student is Smith, and third student again is Smith. You can understand here. But here their ID or student IDs are two different. So two students are having the same name, but logins are different. So their GPA are different. Here you can see if this kind of record I am managing here, this particular record is having the cardinality 3 and degree 5. When I am saying degree 5, you can count the attribute number 1, 2, 3, 4 and 5. So this number of attribute is known as a degree, and cardinality is basically number of entries, number of record in this particular table known as a cardinality number 3 for this example. So these are the some of the typical basically example to understand the data and their relationship, and there also unique identification of the record. So what a database is and is not. The word database is commonly used to refer to any of the following: your personal address book in a Word document, a collection of Word document, a collection of Excel spreadsheet, a very large flat file on which you run some statistical analysis functions, data collected, maintained and used in a airline reservation, data used to support the launch of the space shuttle. So these are the some typical example of the database. It can be anyone. Some of the examples are this. So how you will model the reality? These are the typical examples. Here you can see that The reality is a structures and the processes. If you want define this reality, so you will be using the DDL. This is a data definition language, and this is a green color. Here the database system, and within the database system we'll have the database. So database system is a software package, and here in the database you'll be storing the actual data. Before storing the data, you have to define this data, and the data manipulation, when the you are applying the some of the manipulation processes on this data, then you will be using the DML. A database is a model of a structure of the reality. The use of database reflect processes of reality. A database system is a software system which support the definition and use of the database, and DML and DDL already we explained about it. So today we'll close here. Basically, there are two classes on this. So till now, whatever we have understood, now this particular part is basically to understand the what is the database, and why we should use the database, what are the advantages, and what are the advantages of this database system.